Welcome back to BLOCKTV. This is Chain Breakers. And we're joined today by Evan Shapiro, CEO and co-founder of O1 Labs, the team behind Coda Protocol. Evan, thanks for joining us.
Yeah, thanks for having me.
All right, so to start us off, the Coda Protocol, which on your website describes it as a, quote, cryptocurrency with a tiny portable blockchain. What does that mean? What is the Coda Protocol?
So usually when you have a cryptocurrency, you have to download the whole history of the chain if you want to verify. And as you might imagine, this gets kind of large over time. For Bitcoin, hundreds of gigabytes. It's just a big chain you have to download. That's bad for decentralization, bad for usability. What we do instead with Coda is we replace that history with a small zero-knowledge proof that's only about a kilobyte. So you just got down with the zero-knowledge proof, and you can use the chain instantly. So it's better for decentralization, better for usability.
Right, but there still has to be nodes that are actually do have the entire blockchain on it, no?
So not quite. So what we do is nodes, there's some nodes that have to store the full current state of all the accounts. So let's say that there's 1 million accounts in your system. Then you have to store the current state of the accounts for the consensus nodes. But you don't have to store the whole history of those accounts. You can if you want to, if you really want to audit the whole history of the chain. But by default, you don't have to do that to do consensus, which means that if you want to run a consensus node, then you just have to download this little zero-knowledge proof and the current set of nodes, current set of accounts, which is way smaller than the whole history.
Mm-hmm. But if the default is actually to not hold the entire record of the blockchain, then what is the guarantee, or who is holding the entire record? Is there a possibility it might just be lost?
So no, it's all. So let's think, what do we actually need to use a cryptocurrency? We need the current set of all the accounts. We need the current states, and we need a proof that that current state is correct. We can put whatever we want in that current state. We can put all the data for all of our smart contracts. We can put all the balances for all of our accounts. And that's still going to be way smaller than the history. But the important thing we need is a proof that there was a correct history backing the current state. And that's what the zero-knowledge proof gets us. It gives us a proof that's equivalent to the whole history that the current state is correct. And then you can download that zero-knowledge proof to your browser, to your phone, wherever, and you get a proof that you can trust the current state.
All right, so essentially the Coda Protocol allows you to work, right now it just keeps the current state, in which case, you're able to check it. But essentially one of its features, if you would say, is that it doesn't necessarily keep an immutable history record.
I mean, I guess it really depends. So I think yes. So the current state does hold everything you'd ever need to use the blockchain in Coda. And the immutable history, it's still there. It's just that by default, using your credit card somewhere, you don't need to look at your transaction like a year ago to use your credit card. You just have to trust that it works. And the trust you get with a credit card is so-so. The trust you get with Coda is perfect. So right now, yes, to do a transaction, you need to look at this whole history. But if you think about how we interact day to day, it's not really the case. And if we can do that with perfect trust, it puts us in a really good place.
Mm-hmm. So I mean, it seems like its main use case is more for transactionally. Is the goal there to kind of be a sort of a Bitcoin Cash competitor for peer-to-peer transactions and spending?
We think of it so yes. So one thing that you can do with Coda is you can do payments. But the other thing you can do with Coda is you can still do some programmatic things on top of just pure tokens, pure value. So you get a little more than the Bitcoin level. You get tokens and you get programs on top of that. And down the line, we will have full programmability using zero-knowledge proofs. Mm-hmm. So it's yeah.
Right. But if you're enabling smart contracts on this blockchain, then eventually won't there be enough smart contracts that are heavy enough that all of a sudden you go from this lightweight blockchain to a much more bloated blockchain?
Well, it really depends how much space you leave for the smart contracts. So if you do something like Ethereum, where anyone can put any data into the blockchain and it stays there forever, yes, then you're going to end up with a very bloated chain. What you can do instead is you can have a limited amount of space that's still very large, on the order of a few gigabytes. That's the active data that's used for the chain. And then you can buy space on that active set. Which makes sense, right? You shouldn't be able to just put data onto the chain that stays there forever. That's a cost that you're putting on everyone forever. It's a huge externality. So you should just have kind of a finite set of data that is the current active set of data. So anyway, we can do smart contracts through that.
And you guys kind of achieve this through something called recursive ZK Snarks. Do you want to explain that to someone like me who doesn't have that intense of a technical background?
Yes. Okay. So here's how I would explain it. So ZK Snarks are a new cryptographic primitive. If you've heard of hash functions, public keys, it's sort of in the same domain as that. What it lets you do is it lets you check a computation very cheaply once a proof is made. So what does that mean? It means that, let's say that you have some program that you want to run, say the program is checking a blockchain. Usually what you'd have to do to see what the output of that program is, you have to run the program. And if the program takes forever to run, then it's going to take a long time for you to run that program, check the blockchain. What a zero knowledge proof does is it lets you take that program and make a proof for it. And then someone else can come along, look at the proof, and they don't have to run the whole program, but they know what the output would have been if they had run the program with 100% guarantee. Does that make sense?
Yeah, it does, and I mean and I guess that's what enables your kind of the protocol to run so lightly. And is that kind of tie in with the inclusive consensus? Because you guys don't work on proof of work. It's more proof of stake. What's your consensus model?
That's right. Yeah. So we use proof of stake. In particular, we use Ouroboros, and Ouroboros plus these ZK Snarks is a very powerful combination, because it means that as a user, you have to download just a very small proof and the small current state to be able to use the chain. But also with Ouroboros, we can have an arbitrary number of consensus nodes. So we're not limited to, maybe like a few dozen or even a few hundred. We can have thousands or tens of thousands or perhaps even more consensus nodes on Coda, which is amazing for decentralization, right? If you think about kind of a convergence towards bigger and bigger mining pools, new proof of stake protocols that in those cases do have a limited number of people that can do consensus on the network. We wanted to reach another order of magnitude of decentralization.
And because it's kind of so light, the blockchain requires very little processing power as well as memory. Do you envision that someone could run a consensus node on their smartphone?
Yeah, I think they could. We're going to have support for running basically a node that can, with 100% guarantees, store, send, transact, and do whatever computations we have in Coda on phones and browsers. But down the line, yeah, for sure, you can definitely have kind of a full consensus node also on something like a smartphone.
Yeah, I think that would be a real game changer. Once someone could boil it down to that level, everyone has a smartphone on them. It could really define what decentralization is. Now, tell me a little bit about the consensus token program.
So so we have a program out now, the Genesis program for the testnet. And the way this works is, like I mentioned before, we can have an arbitrary number of people on the network doing consensus. We want to have that going for mainnet. So this is a program where you can participate in the testnet. You can start participating now, and you'll get a grant of tokens on mainnet. And then you can help be one of the people that are helping run Coda's consensus. We're accepting up to 1,000 people to the program, and we've already had a huge amount of inbound interest. But if people are interested, please just check it out on our website and stuff.
That sounds really awesome. Now, going back now to use cases, where essentially, in order to prove a transaction is correct and valid, it just has to connect with the state. There's not much more information. Is there the risk here that this could be used by criminal actors to kind of transact, money launder, and do other nefarious gains because you don't have all those extra history checks?
I mean, I think there's a risk of that with basically any technology. I think with any technology, it's not necessarily good or bad. It's neutral. It depends on people use it. So I think it's up to us in the community to try to shepherd things towards what we consider to be good use cases and actually things that are good for people and good for the world. But it's for sure a tricky problem. I think that a lot of people are facing and going to face. So yeah.
And at this point, how short do you have your transaction time taking? How low did you guys get it?
So let's see. I think it depends what you mean by transaction time.
Let's say I come into your store. I want to buy this object. And I want to use the Coda Protocol. How long does it take me from when I press that button till you receive it?
Got it. Well, the answer right now is 3 minutes because we're still on the testnet and we're still getting the time down. But the answer in the future will be, in the order of tens of seconds. And then you'll be able to get a proof back that actually fully verifies that transaction has gone through.
But if it's taking me tens of seconds to get a confirmation through your network, what incentive is there to use the network? I mean, if it's so light, but you still have to wait that time, there are, of course, traditional systems like credit cards. They're instantaneous. There are also other competing blockchains that are much quicker than that. Why Coda Protocol?
Yeah, let's split it into two things. So I think, okay, so if we talk about like the in-store use case where you're actually using it in like a physical location, I think we're going to need something on top of Coda to make that like, super possible. Although like, to be honest, 30 seconds isn't really that bad if you're like buying a coffee or something, you'll know pretty quickly. But we imagine Coda originally being used for more like kind of digital use cases that work on the internet. Because for those you have, a bunch of advantages. You don't have like the same, like, there's already such a huge network of like things working for in-store like kind of payments with like tokens and not with tokens, with like, fiat currencies. But online, there's kind of a wide open place to like actually deploy new digital tokens that have programmatic value on top of them, which we think is like way more interesting and a place for cryptocurrency to kind of make their mark way faster than like, at like your local restaurant or store or something.
Now, you used to code, switching gears a little bit, you used to code for Mozilla, which of course famous, for their open source, trumping. Are you planning on making this open source as well?
It actually already is open source. So yeah, it's all fully on our GitHub. I think like literally everything we've written is like, on that repository. You can check it out. You can go to our Discord and watch our like developers and the community members chatting in real time about pull requests and other coding related things. Yeah.
All right, very cool, Evan. Very exciting project. I'd love to hear more about it going forward. Thank you so much for joining us here on BLOCKTV. And for all our viewers at home, if you want more on blockchain, crypto, or tech, check us out at blocktv.com.
For more news and updates, follow us on